All right, thanks, Jana. So, if ever in the back you can't hear me, just holler and I'll put the microphone someplace else here. But so yeah, I imagine some of you live up here, and I imagine some of you are from the Front Range, and some of you are from those other states there. But wherever you're from, you probably drove up I-70 in the past there. And between here in Dinosaur Ridge is about 60 miles east of here, right down I-70. You can get there in an hour from here. Of those 60 miles, about 59 of those miles are filled with wonderful granite and gneiss and those old crystalline rocks that are the core of the Rocky Mountains. And we're not going to talk about any of those, but those rocks are part of the Idaho Springs Formation, which is about 1.7 billion years old. And I'm going to talk about some big numbers today. So just so don't want to confuse everybody. This piece of paper is about 6 feet tall, about as tall as my son, and the bottom represents the age of the Earth, about 4.6 billion years. So the Idaho Springs Formation is about 2/3 the way through Earth history. If you go up here to about 520 million years ago, that's about the first time that the animals that you would recognize as animals exist on Earth. You know, before then there's some single-celled and small things you might need a microscope to see. But then way up there, that little bar at the top is the Mesozoic area, the age of the dinosaurs. And that's the part I'm going to talk about. And not even just all of that, but even the top half of that. So just the last % or 2 of Earth history. So it kind of seems like those dinosaurs lived a long time ago, but in the big scheme of things, it's pretty recent here. So today, I'm going to try to describe 4 different layers, 4 different environments, 4 different zones right here. And the rocks here have been eroded away, so we don't see evidence of them here, and that's why you have to go down to Dinosaur Ridge to see that, okay? So that's not a good plan. So we're going to go through 150 million years of history in 50 minutes. So I'm going to talk real fast, but don't be shy if you have any questions. So to start with, the oldest rock I'm going to talk about, if you drive over the mountains, you go down as you go into Denver, there's a hogback, that ridge, and you can see those dipping beds that are dipping down to the east. And the layer on the west of that is from the Jurassic period, 150 million years ago. That's when Stegosaurus lived. And when in that Jurassic period, in Colorado here, the mountains did not exist yet. And there were slow-moving rivers that came from Denver out to Utah, up to Alberta, Canada, down to New Mexico. So this whole area was flat. You kind of think about maybe the Serengeti, or maybe what it looked like in South Texas, where it's flat all the long area and winding, slow-moving rivers along there. Well, to jump ahead a little bit in time, in 1876, when the year that Colorado became a state, a teacher from the Colorado School of Mines was walking along that ridge, kind of looking for fossils, and he started finding some things. He started finding bones. Not these boring old cow bones like that. No, nothing like that. But what he found is a thigh bone, a femur that's about 6 feet long. And he said, I think I found something pretty special. So that's my little grandnephew for scale there. So he wasn't a paleontologist. He wasn't even a trained geologist. So that teacher rolled these bones down the hill, put them on the train, sent them out to Yale in Connecticut, and the scientist out there was the one who just started describing these bones to tell you what they were. Well, unfortunately, he didn't find a whole skeleton. They're all put back together. These bones, these animals had died. They'd washed down the river and kind of built up in the bends of the river. So he found bits and pieces of bone. So like one thing he found was one of these. And he said, if you found that, what would you think it is? Is it one of those? Is it one of those? Is it a kneecap? What do you think it is? So it is in fact a plate from the back of a Stegosaurus, but in 1876 that word Stegosaurus didn't even exist yet. So first of all, they thought these things were plates that are lying on the back of some animal, like shingles on the top of a roof. So when they named Stegosaurus, they actually called it, the name means roof lizard. Later on, they found out, no, just like this picture here, these plates stand up on end. And what could they be for? You know, in the 1800s, many of the geologists, most of the geologists, unfortunately, were a bunch of old guys. And these guys think, you know how guys are. They think everything's for fighting and defense and armor and protection. And that's what they thought too. But if you look at the top of these plates, I mean, this is just the copy of one, the plates are pretty thin. And along the side here, they have these grooves where the blood vessels would have gone down there. So if the meat eater at the day had bit into these bones, the bone would have broken and it would have bled a lot. So does that sound like really good armor? Maybe not so much. So later on, some people start thinking what these animals are really, what those plates are really for, are for heating and air conditioning. So on a cold morning up here in Frisco, Mrs. Stegosaurus woke up and she said, well, I'm kind of cold. I'll see where the sun is. I'll face that way. And these big plates would absorb the heat and these blood vessels would take the blood down into her body and warm her up. And this afternoon it's going to get pretty hot here. So she'd stand the other way and the wind would go by and heat would radiate off the side of these plates. So there's like heaters, air conditioners. So it's pretty cool. So if we think about what Colorado looked like at that time, it was slow-moving water along here most of the time. What's that? That's water down there, and that's the sky up there. So it's nice and a flat area here, and Stegosaurus would have been walking right here. If we had gone back and looked at a map at the time, Colorado looked a little bit different. There was this little bit of the ocean that was kind of coming down. It didn't quite reach Colorado. And in the middle there, it was pretty dry. So that kind of gives you a picture about what Frisco looked like 150 million years ago. It's hard to believe, huh? You know, so one of the animals they found was Stegosaurus. The meat eater that lived at the time, the carnivore, was a dinosaur called Allosaurus. So Allosaurus was, I mean, a lot of people, their favorite carnivore is T-Rex. We'll talk about him a lot later there. But Allosaurus was not as big as T-Rex. But if you look at Allosaurus, if you looked at the fossil bones, what could have told you that it was a carnivore? How would you know that an animal like that is a carnivore? What do you think?
If it had sharp teeth.
So Allosaurus had teeth that looked like steak knives. And even the real, this is a copy, but the real ones, they even have serrations on the edge like steak knives for ripping that meat apart there. Anything else that would tell you it's a meat carnivore besides the teeth? They got claws that look like that. So these claws, you know, and even a couple of you have been around for a few years, but even us with white hair, we haven't been around to see Allosaurus eat anything. But in paleontology, we use a rule. We say the present is the key to the past. So we look at animals today that have sharp teeth and sharp claws, and they're mostly carnivores. I bet you can name 100 of them, right, real fast. A few of them live right around here today. So Allosaurus was the meat eater that lived at that time. And the third group of animals that we found evidence for down at Dinosaur Ridge were things like Apatosaurus, these long-necked dinosaurs. And you could probably name a few other long-necked dinosaurs like Brontosaurus and Brachiosaurus and things like that. So these dinosaurs were walking right around here. Like I said, this was people have found fossils of these kind of dinosaurs in Canyon City, Colorado, in Grand Junction, Colorado, and all the way up to Canada. But the first ones were found, things like Apatosaurus and Allosaurus and Stegosaurus, were named after the bones found right down at Dinosaur Ridge in 1876. That's one reason why Dinosaur Ridge was named exactly 50 years ago this year, named to be a National Natural Landmark. That means we're under the umbrella of the National Park Service and we get a plaque. No money, but that's about it. So, but one thing I think it's really kind of interesting when you think about most of these dinosaurs, if you can take them apart and look at them, the bones look a lot like ours, and you can see, femurs and tibias and fibulas and all things. Most of us don't have a long tail like that, but besides that, they're pretty similar in a lot of ways there. So down there at Dinosaur Ridge and many other places around Colorado, they found bones for these dinosaurs. Like I said, the ones that we found down there, they washed down the river, they all got torn up, you got bits and pieces of them. So it's not enough to make a museum quality specimen, but when you go down to the Denver Museum of Nature and Science and see the Stegosaurus, which is from that same age, that specimen came from Canyon City, Colorado. So it's a pretty special place around here. So if you go out to Dinosaur National Monument in Vernal on the Utah-Colorado border, or many of those places, you'll see those same kind of animals that were living right here in the Jurassic period 150 million years ago. So I think that's just pretty neat to think about that. Also down there, we have footprints of some of these animals, and we don't have the footprints from the top of these big long-necked dinosaurs, but we have footprints from the bottom. So if you can imagine that, one day, maybe it was a Wednesday morning, 150 million years ago, there's a nice flat layer of sand alongside that river, and one of these dinosaurs came, stepped in the sand, left a hole, and you've all left footprints in the sand, and if the sand is clean, the kind of beaches you want to go to, the footprints blow away pretty fast. But if it's got some mud and clay in there and it hardens in the sun, it could get pretty hard, and the next layer of sand would wash in and fill up. And these footprints at Dinosaur Ridge sat there for 80 million years until the Rocky Mountains formed, and then they got pushed up on end, and they were like that until 1936 when they built the road down there. The bottom half fell off, and so we see things that stick out at the bottom of the tracks. So a couple of the tracks we see down there in this Jurassic rocks are about 3 or 4 feet across, and the only animals alive ever who could have made tracks that big are those long-necked dinosaurs like Apatosaurus. So imagine Frisco with slow-moving rivers. I see a Stegosaurus out there. I see an Allosaurus over there that's chasing her. So those kind of things were around here. And I guess one last thing about the Jurassic, when these animals walked here, flowering plants had not evolved. We're just starting to evolve. So there's no grass, no aspen trees or apple trees or maple trees or anything like that. So these animals, the herbivores like Stegosaurus, would have eaten ferns and cycads and pine trees and things like that. So it's a really different environment. Yes, ma'am. So the question was, were the dinosaurs all over the planet? And yes, so dinosaurs have been found on every continent except Antarctica. I don't think they found them yet because it's all covered with ice. But when the dinosaurs started to live at the beginning of the Mesozoic period, all of the continents were connected. So animals were able to move from what is now America to Asia to Europe, and then after the continents started splitting apart, they evolved in different kinds of genus and species. But yes, they're found everywhere. Dinosaurs have been found north of the Arctic Circle. It's amazing, isn't it, to think how they lived in a time when it's 24-hour a day dark, So it's kind of interesting. Okay, so that's the Jurassic period. And when you come up afterwards, I do have those things I showed you were cast or copies, but I do have one piece of a actual fossil, 150 million year old fossil bone here, and you can kind of see some of the pores in there. Like if we cut one of your bones open, there's a lot of pore space in there, and these bones at Dinosaur Ridge and many other places are filled up with iron and other minerals. So that's why they're heavy and dense and got some of that rusty red-brown color in there. So that's the Jurassic period from 150 million years ago. If we fast forward about 50 million years to what's called the Cretaceous period, 100 million years ago, things had changed. That environment where the slow-moving rivers went away, and if you looked at a map of North America, that ocean had been growing. This is called the Western Interior Seaway, and that seaway extended right down to Colorado, where that star is. And so from here, or Denver, you could look out, see that seaway, and dinosaurs would have been walking along a lovely beach here. Now, on the east side of, so those Jurassic bones were on the west side of Dinosaur Ridge. On the east side of Dinosaur Ridge, there's a slab of rock where we see hundreds and hundreds of these tracks. And I think the interesting thing about those tracks is that they've been found 7 different layers, which means 7 different times. Each of those layers is like a page in a history book, so it tells a different story. But they've been found at different times, and those same kind of tracks have been found up near Boulder, and in Golden, and in Morrison, and Canyon City, and Roxborough Park, and all along where the Front Range is today. If we look at, we made a copy of one of those tracks, and on that side of the ridge, there's actually no bones have been found. Only tracks. And paleontologists say if you find the dinosaur bones, you can figure out how that animal died. But if you find the dinosaur tracks, you can figure out how they lived. Without even seeing any bones from the skeleton, we know that this dinosaur had three toes, or at least 3 toes that touch the ground. The toes are kind of rounded. They're not really sharp at the tops. They didn't have claws, so we can surmise that this was an herbivore, a plant-eating dinosaur. You can tell that from the tracks we see all these places, you can tell which way they're going. One of the rules of thumb we use in paleontology, if you take the length of the track, this is about 10 or 12 inches, and multiply by about 4 or 5, it tells you how long the leg is. So this dinosaur would have a leg that's about 4 or 5 feet high. This animal might be the size of an elephant. And even by looking at the trackway there, we can learn about the behavior. At one place, there's big tracks and small tracks walking right next to each other, parallel. It gives you the idea that there's some parental care, that Big Mama or Big Papa is taking care of Junior. Another place at that site, we have 4 different trackways, or maybe it's 6 trackways, all in parallel going along. It gives you the idea that dinosaurs were traveling in herds. Today, remember, the president is key to the past. Today, elk up here in the mountains travel in herds to be safe. We think the dinosaurs did exactly the same thing 100 million years ago. So we think that those animals that made those tracks were something like these duck-billed dinosaurs called hadrosaurs. Now, if you came from someplace, some far away, I don't know if anybody's here from Europe or Texas or someplace like that, but you came here and you were walking around up in the mud and you saw some modern tracks, you might not know if they're a mule deer or a white-tailed deer or maybe a young elk, but it's something in that family. And that's what we know from the tracks that were made up there, is that it's something in that family of these duckbill or hadrosaur dinosaurs. So it gives us a clue as to what's going on there. Like Janice said, I've been volunteering out there for since 2005. How many years is that? 18 years. It's a long time. And when the tracks haven't changed a bit, but our story changes. We keep trying to say who actually made those tracks. It's like it's like a crime scene novel. Who done it? And there's an animal called Eolambia. That's what this animal is. That's kind of in that family. And their bones have been found from Eolambia in Utah in about the right time frame, which is about right there. I bet a lot of you have been to the Garden of the Gods. In the 1800s, they found a skull of a dinosaur there, and actually, they got a little confused, and they put it in the wrong age of rocks, and they didn't know quite where to put it. But scientists from the Denver Museum of Nature and Science was there a few years ago, and he said, you know what, that doesn't look right. So he went back and found the field notes of the person who described that dinosaur originally, and he said, you know what, it's about the right age for those things that we see at Dinosaur Ridge. So maybe that's the track maker. And he named that dinosaur Theophytalia. Theo means God, and Phytalia means garden. So it's the God garden dinosaur. So when you go down to the visitor center at Garden of the Gods, if you go into the back room, you'll see a dinosaur that might be the one who made those tracks there. In addition to those animals, those duck-billed dinosaurs that made most of the tracks, we see another set of tracks that look like modern bird tracks. They have really sharp toes, and they're probably from an animal like Ornithomimus. You know, ornitho means bird, and ornithologists study birds, and a mimus means mimic or copier. So Ornithomimus is the bird copier, the bird mimic dinosaur. And even though it is in the family with all the carnivores, all the meat-eating dinosaurs, it's got those sharp claws, it probably wasn't the meanest dinosaur that walked around Frisco, because when they found it in other places, it's got no teeth. It's just got a beak like a bird. So I think that's kind of interesting. So it might have eaten eggs and lizards and plants and little mammals that were, just little things that were scurrying around there. So Ornithomimus would have lived here, those duck-billed dinosaurs, and they also have the big carnivore is something called Acrocanthosaurus. And Acrocanthosaurus is probably, if many of you saw him walking down the street here, you'd say, that looks like a T-Rex. It kind of does, not quite as big. One thing that's kind of cool about Acrocanthosaurus is that our track specialist that does all the scientific work for us is a man named Dr. Martin Lockley from the University of Colorado. And out in western Colorado, up by the Utah border, he found a bunch of these scratch marks where a carnivorous dinosaur had made these scratches in the wet sand. And what we think, remember, the present's the key to the past, some animals that live today, some shorebirds, when they're mating, the guys make these scratch marks in the sand to say, hey, I know how to make a nest. Yes, come with me. And so we have a couple examples of that at Dinosaur Ridge, but there are a whole lot of really good ones out there in western Colorado. Unfortunately, the places out there are really inaccessible, so you have to come visit us down there. So all those dinosaurs, all those tracks you're seeing right there. So it's kind of interesting to think that these guys and gals walked all around what is now Colorado, but where the mountains are now, since they've been pushed up, all those rocks, all their tracks, all their bones have been eroded away. And out in eastern Colorado, it's all been covered up with dirt and sand and grass, and so there's nothing. So that's why we just see them right along the Front Range. So pretty limited in where we see them, although we guess they probably live. They're pretty more widespread in the past. So that's what it kind of looked like. I'll show you this too. If we made a map of the tracks at Dinosaur Ridge, we just see about 300 tracks were made there, and so it's pretty cool to see big tracks and small tracks. Give the idea of family behavior and herd behavior. So it's really a neat spot. That's a good question. She asked, how far could these animals have roamed? So first of all, we don't know. But if we look at modern animals, they travel pretty far. A second thing is, I mentioned that some of these dinosaurs were found north of the Arctic Circle where it's dark for 24 hours, so maybe they might have migrated. So we really don't know. If they'd, I'm not sure how we could figure that out. It's really a great question, but it's hard to know how to figure that out. But we do know that over the years, over the millions of years, dinosaurs migrated all around the world. So at some point, they did some serious moving there. Yeah. Yep.
Is that graphic available on the Dinosaur Ridge website? The one we were just looking at?
With the map there? I would say it is probably not there. So come up afterwards, take a picture of it, or I'll send you one there. Yeah. Yeah, and by the way, yeah, at the end, come up and you can look at all these things a little closer there and see what's going on. So yeah, so that's good. Yeah, Steven Spielberg lies to us just a little bit, you know, but Stegosaurus would have never seen these duck-billed dinosaurs that were living here. So each genus or species of dinosaur might have hung around for 1 million or 2 years, you know, but we're talking about, you know, tens of millions of years. So no, different dinosaurs lived at different times. So we started off with those Jurassic dinosaurs 150 million years ago when Stegosaurus walked here. And I should have, I got too much to say. I should have mentioned the reason this Stegosaurus is painted with this Colorado flag on the side is because about 40 years ago, a group of 4th graders said, you know what, Stegosaurus is really cool, and we don't have a state fossil. So this 4th grade class went to the legislature, they went to the governor, that's Governor Lamb back there, and they had signs that said, we love Stegosaurus. And the project lasted a couple years, but they finally got Governor Lamb to sign the bill that says Stegosaurus is our state fossil. Since the first Stegosaurus ever found in the world was found right here, it's a pretty appropriate one. So, yeah, and he's kind of cute too. So anyway, so Stegosaurus was walking here 150 million years ago. These tracks were made 100 million years ago, and then things started changing again. I had mentioned that seaway that was formed, and that seaway kept growing more and more and more. So there's Colorado right down there. Eventually, a couple million years after this, the seaway connected to the Gulf of Mexico. So most of Colorado was covered with water for 10 to 20 million years. So if we could go back to Frisco about 80 or 90 million years ago, this is what it would look like. It's kind of crazy, isn't it? How long can you tread water? Yeah. So, yep. So this seaway, don't think of it like the Pacific Ocean, something more like the English Channel. A few hundred meters, something like that. So the animals that would have lived that time at many places along the Front Range, in this layer of rock, they have found fish scales, they found shark's teeth, they found these things called ammonites, which are related to octopuses, and except they have hard shells, and they found those big swimming reptiles like mosasaurs and elasmosaurs. So all those things were swimming right here in Frisco then. And I might mention that things like mosasaurs, things like elasmosaurs, all those swimming reptiles are not dinosaurs. They lived at the same time as the dinosaurs, but their bone structure is all different, their evolution is whole different. So you know, if the movies always throw this stuff in together, the things that fly, like pterosaurs, pterodactyls, are not dinosaurs either, because their bone structure is all different. If you think about today, if I asked you how can you differentiate between a bird and a reptile and a mammal, you're probably going to mention a lot of things that aren't fossilized very well. You're going to say it's warm-blooded or cold-blooded, or it has hair or feathers, or it has live birth or eggs, and a lot of other things like that. And most of those things aren't fossilized very well. So with ancient animals, we classify them on the bone structure. So
what is a pterodactyl?
So it's a reptile. It's a flying reptile. But pterodactyls and these swimming reptiles and dinosaurs and the ammonites all went extinct at the same time, and we'll get to that story in a little while here. So that water was 70 million years after Stegosaurus lived there. So it's unrelated to that. It's a long time after that. Yep.
So do we have any?
So it turns out, I think the short answer is environmental change. Things change, and some animals adapt, and some animals don't adapt there. And I don't want to get political about climate change here, but things are happening today. The environment's changing. It's partly our fault, and so some animals can't adapt. If the changes are slow enough, they can adapt better. If the changes are quick, and I'll tell about the time when that happens, I'll talk about that later. So Stegosaurus was 150 million years ago. These tracks are about 100 million years ago. The seaway was 80 or 90 million years. If we jump up to 68 million years ago, that's time when that seaway pretty much dried up. That seaway is going away because the land is starting to rise. We're a mile high now. It's nowhere near that high at this time, but the land was starting to rise. The seaway was kind of drying up or running off, and the environment changed, so our favorite dinosaurs were living at that time. There's a T-Rex right out there. There's a Triceratops over there, and they're walking right along here in this tropical kind of, subtropical kind of environment here. If you're driving down I-70 and you turn right, you go to Dinosaur Ridge and see all this stuff I've been talking about so far. If you turn left and go up in the town of Golden, there's a little trail called the Triceratops Trail where we see tracks from T-Rex, from Triceratops, and some other pretty cool things. So let's talk about some of those animals a little bit here. Let's see. Remember that teacher from the School of Mines that found those bones in 1876? Even a couple years before then, in 1874, he and his students were walking along the side of Table Mountain. If you drive down there, those flat mountains after you just come out of the mountains, and they're capped with lava, lava rock, basalt at the top. But at the base of them, there are sedimentary rocks from about 68 million years ago, and he found a tooth. Now, if you look at that, does that look like a meat eater's tooth or not? Yeah, it looks pretty carnivorous. And he knew that. He said, you know what, I'm not sure what this is. I'm going to send it out to Yale. So he sent it to his favorite paleontologist at Yale, Othniel C. Marsh. And Professor Marsh looked at it and says, well, I don't know what it is. He put it in a drawer. So it sat there for 26 or 28 years. Then some people up in Wyoming named a new dinosaur called T-Rex. You probably heard about that one a little bit there. So T-Rex was named about that time in the early 1900s. This tooth still sat in the drawer until about 10 or 15 years ago when somebody opened the drawer and says, hey, I know what that is. And this is probably the first, this is a copy of, this is the first T-Rex fossil ever found right here in Golden, right along the Front Range, although they didn't know it for 100 years. So it's kind of crazy, isn't it? So everybody knows T-Rex is the biggest carnivore that ever lived, those powerful jaws, those funny little tiny arms, and they would have walked right around here. In New Mexico, where the Philmont Scout Ranch is, they found a track for T-Rex. It's pretty cool. So if you go to most museums around the country, if you see a T-Rex track, that's a copy of that one right there. But we have another probable Tyrannosaur track at our site there in Golden there, and the track is about 4, maybe 3 feet toe from heel to toe, and it's got nice sharp claws, and it's too big to bring along here today, but I brought along a bone from one of his little cousins here. This is an animal foot from a Gorgosaurus, which is in the same family as Tyrannosaurus, but a T-Rex track, a foot, would be about 3 times this big. And if you look at that, next time you go to the zoo or the Hawk Watch or the Audubon or the bird places there, if you look at the toes of a hawk or an eagle, they look kind of like this. And birds evolved from this group of meat-eating dinosaurs, so it's not surprising that they have a lot of similarities. So at that site there, we have tracks from that. We have a track from kind of another duck-billed dinosaur that lived at a different time there, so we've got that. And then we've got a whole series of tracks, half a dozen or more, from Triceratops. Now, Triceratops is another story about that. In the 1880s, a teacher was down in Denver, near where Federal Boulevard is today, and he was digging around, and he found something that looked kind of like this. He said, "What's that, you know?" So he said, "You know, I better send it to my friend in Yale." And of course, they were not doing this all just for scientific things. They were getting some financial compensation for things. But in his notes, or Professor Marsh out of Yale, they got confused about how old these rocks were. They thought it was a much younger layer of rock. And he looked at this thing and said, "I don't know what that is. I think it's a new kind of buffalo." So Professor Marsh wrote a scientific article about a new species. It's called Bison alticornis. You can look it up. And then a year or two later, they found some other Triceratops bones in other places and said, "Oh, oops, I made a mistake." And so once again, maybe the first Triceratops bones ever found were found right in the Denver area, but they didn't know it. And we kind of laugh at that, but really just have a few bits of bones and pieces, and it's kind of confusing. It's hard to imagine them naming all these dinosaurs. In the 1870s and 80s, when they did this, even the name dinosaur was new. The name dinosaur just was coined in the 1840s, so there wasn't very much knowledge about it. And some of you, if you look at those old textbooks, they had these reptile-like things living in swamps and, cold-blooded things. Now we know things are a little bit different along the way here. So T-Rex, Triceratops, have evidence for that there in Golden. And I think the coolest thing has nothing to do with dinosaurs at all. At that site, they see beautiful palm frond fossils, big ones about 3 feet around, and deciduous leaf fossils. And so it's really an interesting spot to learn about the environment there. And so that trail is right along the side of that Fossil Trace golf course. If any of you are golfers, it's a pretty good golf course owned by the city of Golden there.
Were the dinosaurs warm-blooded or cold-blooded?
That's another good question. Maybe, And we're looking at a big group of animals over a long period of time. So one idea is that some of the earlier ones, those slow-moving, long-necked dinosaurs, would have had to be cold-blooded, because if they were warm-blooded, they just couldn't generate enough heat to do all that stuff. But at the end, these raptors and these T-Rex were fast-moving, they were aggressive, and they were probably warm-blooded, at least to some degree. And maybe it's not an either-or thing. Maybe there's somewhere in between there. So it's really cool. But questions like that, again, and how do you figure that out? It's really, really hard to figure that out just based on the bones.
Send it to Yale.
Yeah, we'll say, yeah. We'll put it in a drawer in Yale and see what happens there. So that's kind of we see all these different layers here, all these different environments. When T-Rex and Triceratops lived here, it was kind of a swamp environment. And in fact, at our site there, they have layers of sand and clay and sand and clay and sand and clay, where the sea level was rising and setting and rising and going up and down and up and down. So sometimes it'd be kind of a sandy beach, sometimes it'd be out in the water, and the clay would settle down there. The clay was really valuable, and in the 1870s, the Parfit family moved out here from Pennsylvania, and they started mining that clay. And in that Gold and Morrison area, there were dozens, a couple dozen clay mines. It's a really valuable resource, and there was a big industry in gold in there. It still is today. You know, Coors, during Prohibition, they said we can't make beer. Makes there, and today I've heard that the ceramics division of Coors makes more money than the beer division. So I'll drink to that. So what happened to those dinosaurs? You know, after T-Rex and Triceratops were living here, we had one really bad day. And it's kind of funny. I went back and looked at my geology textbooks recently that were written, I shouldn't say this, but in the 1960s, early 1970s, and they didn't have a very good explanation of why the dinosaurs went extinct. They said maybe they were, you know, getting old and tired. Maybe they have genetic problems. Maybe they had diseases, or maybe there was volcanic activity there. So a lot of guessing, not much answers. Then about 1980, a scientist found a layer of rock right at the top of the age of dinosaurs, right at that line right up there, that had a really interesting mineralogy. This layer was really distinct and had a mineral called iridium in there. And iridium is pretty common in space rocks, asteroids and meteors, and very rare in the Earth. And he said maybe something hit the Earth and that caused the problem. And they started finding that layer in multiple places around the world. In fact, if you want, you could, when you're done here today, if you drive down to Trinidad Lake State Park, which is right on the New Mexico border, I did this last month, and there's this layer of rock right there. It has that iridium in there. And that's the layer that happens right at the age of the end of the dinosaurs. Now, when that happened, my 3-year-old grandson says, "That was a really bad day, Grandpa." And he was right, because this 6-mile wide asteroid smashed into the Earth, into what is now the Yucatan Peninsula. It would have caused huge waves of water to go around the world. It would have caused earthquakes all around. Ash and dust went in the air. Some of the sparks would come down and start fires all around the world. The dust would have blocked the sun all around the world. Plants would have died. The whole food chain broke down. At that time, all the dinosaurs, except for the birds that evolved from there, all the land-based dinosaurs went extinct. The flying tyrannosaurs, pterodactyls went extinct. The swimming mosasaurs went extinct. Ammonites went extinct. 75% of all species on Earth went extinct at that time. And you say, was that good or bad? You know, it's kind of bad if you're a dinosaur. If you want to see mammals evolve, that's a pretty good thing, because you got all those dinosaurs out of the way. And the Denver Museum of Nature and Science just came up with some pretty cool exhibits in the last couple of years. East of Colorado Springs, they found a sequence of rocks that was formed a million years right after that extinction event. And they started finding mammal skulls. And at the bottom of that layer, the mammal skulls were about the size of a rat skull. And they kept getting bigger. By a million years later, they were like the size of a wolf. So you can see how mammals started radiating out, filling all the niches that were available in the environment that were left empty after the dinosaurs went away. So we have evidence of that mass extinction event in the history of the Earth. I don't know, just in this last 10%, there's been about 5 different mass extinction events. Sometimes when as many as 90% of all species went extinct. Let's not make this a 6th one we're in right now. So that's a lot of scary stuff here. So yeah. Well, it certainly could have. And I think one of the things, like with many things in life, it's not just one thing. It's like the perfect storm. You know, if you think about any kind of disasters that happen. Might be a lot of things. So the food chain is really important, you know. And you think about times when the food chain, you know, maybe that's why Stegosaurus went extinct, because the foods they were eating stopped growing as well because those flowering plants evolved, and they weren't used to flowering plants. So things like that. So it's hard, you know. I mean, those are really good questions, and they're really hard to answer based on a bunch of old bones here. But scientists are really getting a lot better at that. So hang around. You young kids are going to have some problems that you're going to have some answers in 20 years that we don't know now. Yep. So the question is, what's the lifespan of dinosaurs? And some people, we used to think these huge these long-necked dinosaurs, as long as 2 buses, you know, 30 tons, they must have lived centuries to get that big. And that's not really true. They can find growth rings in the bones, and many of these dinosaurs have the same kind of lifespan as we do, you know, 60, 80 years, you know, so they don't live, but that means they have to grow really fast. You know, in the spring, if we see a robin nest, you know, those little birds come out. By the fall, they look like they're adults, right? They grow really fast, and we think some of these dinosaurs probably grew pretty fast like that too. So, yep. So the question was about the previous extinction events, and as you get older and older, it gets to be more of a colder case as we go back, so there's less evidence. A couple of them, there's evidence of a lot of volcanic activity at the time. So that's the prime suspect, is that there's huge quantities of volcanic ash that went in the air. Even kind of small volcanoes that happened to, you know, in the historic time, like Krakatoa in Indonesia, the dust goes all around the world. You know, there's the time when there's a volcano somewhere, and someplace else they say, well, this is the summer that nothing grew on this side of the world, you know. So I think maybe the most likely case is volcanic activity. However, we don't know. It could be the asteroid or a meteorite there. So I'm going to, you know, wrap up a few things here, but I can stay around all afternoon and talk about these things. But you know, before we wrap this up, you know, I'd like to say, you know, what do I want you to do? First of all, there's some really cool. Thank you. I was going to step on that. You're saving my life there. So first of all, you know, go to some of these cool dinosaur places. There's a new dinosaur museum out in Edwards, just west of here. Out at Grand Junction or Fruita, there's a really good dinosaur museum. Dinosaur National Monument up in northwest Colorado is fantastic. And down in Denver, the Dinosaur Ridge and the Morrison Natural History Museum are really good. One of our former board directors at Dinosaur Ridge says, you know, dinosaurs are kind of like the gateway drug to science. We have to get kids excited about dinosaurs, and then they might turn into biochemists or nuclear physicists or whatever they are. So, you know, getting people hooked on this cool science is really good. When I started doing my tours, I said, I want everybody who comes here to be a paleontologist. And I realized that's not a very good idea. But we want everybody who looks at dinosaurs to learn how to be good scientists and how to think critically, because we're all going to be voting on all this scientific stuff, whether it's water use or vaccines or air and things like that. So we've got a lot of things we got to solve, and we need good science. So with that, I'm going to stop, but I will be around here if you have any questions. So. I do have some brochures. If some of you don't know where dinosaur